Dear students, today we will discuss enantiotopic ligands or the phases. Already we have discussed the homotopic ligands and phases. In today's lecture we will discuss the enantiotopic ligands and phases. Okay, for this we have the first example, that is the propionic acid. Okay, when you replaces HA with the deuterium, okay, you replace HA with deuterium or HB with deuterium. Okay, to find out the whether your ligands is enantiotopic ligands or the homotopic ligands, we have the two types of criteria. Already we have discussed the by considering these criteria we will predict the whether your ligands are homotopic ligands or the enantiotopic ligands or the diastereotopic ligands. Okay, these criteria are the substitution addition criteria and the symmetry criteria. We will discuss the by using the substitution. Okay, H is substituted with the deuterium or HB substituted with the deuterium. That is first criteria. By using this criteria, we can predict the whether these two groups are these two groups are the homomorphic groups. Okay, homomorphic group means when you isolated these groups, it looks like same, identical, and superimposable mirror images to each other. Okay, therefore they exactly match. HA and HB exactly match. Therefore these are the homomorphic ligands. Okay, when you firstly replaces HA with deuterium, then okay, these two compounds is produced. Okay, firstly these after the replacement it will produce as the chiral center. Okay, therefore this is the prochiral center. This carbon is the prochiral center, because after one step your compound is converted into chiral one. Therefore this before center is called as the prochiral center. Okay, one process is carried out on this molecule, you will obtain the chiral center, that is called as a prochiral center, that is called as a prochiral. One step before molecule was not chiral one, but after one step, within a single step, your molecule become chiral one. Therefore the first previous molecule should be prochiral. Okay, therefore when you look these two molecule, these two are the enantiomers to each other. Okay, these are not superimposable mirror images to each other, and that is the enantiomers. Okay, by replacing HA or HB, you will obtain these two compounds are enantiomers to each other. Therefore these two ligands or atoms HA and HB is considered as a enantiotopic ligand. Okay, by substitution method we have predict that these HA and HB are the enantiotopic ligand, because after replacement of HA or HB the two compounds is produced. These two compounds are enantiomers to each other. Therefore after such production of enantiomers, by replacing of these homomorphic groups, obtain the enantiomers, that is called as the enantiotopic ligands or protons or the groups. Okay, therefore in enantiotopic ligands means that it produces the after chiral center is also produces in enantiotopic, but in homotopic ligands will not produces the chiral center. But after replacement of the enantiotopic groups, you will obtain the chiral centers, and therefore the previous compound, okay, before replacing HA and HB, that compound is the prochiral compounds. Okay, prochiral compound means what? By after replacing of the one single steps, your molecule is get converted into chiral center, and the previous molecule is called as the prochiral molecule. Okay, like that way we can define the enantiotopic ligands. We have another example. That is the butane one. Okay, when you replaces HA with deuterium or HB with the deuterium, you will obtain deuterium is there, HB, CH2 and CH3, and secondly okay, these two compounds are chiral center is produced. If you replaces any one H homomorphic HA and HB atoms with deuterium, you will obtain the chiral center compounds, and these two compounds are enantiomers to each other. Therefore, these HA and HB are enantiotopics, ligands or atoms. Another examples which are not present at the same carbon, mesotartaric acid, HA and HB. Okay, these are the mesotartaric acid. Okay, firstly you replaces the HA with the deuterium or HB with the deuterium. Okay, HA deuterium is replaces, HB as it is. Okay, at the secondly HA as it is, deuterium is there, OH, OH, COOH and the COOH. Okay, when you rotate this molecule through 180 degree, okay, 180 degree rotation, okay, when you rotate, OH will become at left hand side and deuterium will be on that side, and HA, COOH and the COOH. Okay, when you look these two molecules, these are the non-superimposable mirror images. Therefore, these are the enantiomers to each other. Okay, after replacing of HA, you will obtain the first enantiomer. After replacing HB, you obtain the second enantiomers. Okay, after replacing HA or HB, you will obtain the enantiomeric pair. Therefore, HA and HB are enantiomers to each other. Okay, this is the first criteria. By the substitution, you will find out whether your groups, atoms are enantiomeric, enantiotopic. Okay, we have suppose such group is there, and when you add from top face and bottom face, you add the RMGX. Okay, therefore you obtain CH3, chiral center you obtain. Okay, correct. Okay, these two different compound is obtained, and which are the enantiomers to each other. Bottom, when you add from the top face and when you add to the bottom face, two different compound is obtained which are enantiomer to each other. Oh, okay, therefore such type of phases is the enantiotopic phases. Okay, if suppose we have transbutane compound is there and you add the per acid, there is two possibility to obtain the compounds. Okay, in this case meso compound is not obtained. Okay, first top face, when you add the per acid from the top face, no meso compound is obtained, or you add from the bottom face, no meso. Okay, two different compound is obtained, and which are the enantiomers to each other, non-superimposable mirror images to each other. Therefore, these faces, top face and the bottom face, these faces are the enantiotopic faces. Okay, when you add the C double bond addition, okay, by addition or substitution, first we have substituted the groups and try to find out whether these are the enantiotopic groups or atoms, or these are the addition. Okay, by addition you can also find out the phases. Okay, enantiotopic phases. Okay, these are the enantiotopic phases. In this compound, these two phases are the enantiotopic phases, and this compound, top phase, bottom phase, these are the enantiotopic phases. Now the second criteria is the symmetrical. If you are two groups, okay, two groups, which are these two groups? For example, we have seen the such example HA, HB, propaneic acid. If such two groups exchangeable by plane of symmetry or SN axis of symmetry or inversion of symmetry or point of symmetry. If such these two groups is exchangeable with such types of symmetries, then these groups should be considered as the enantiotopic groups or enantiotopic faces. Okay, if such types of the symmetry is observed. Okay, plane of symmetry is there or SN axis of symmetry is there or inversion of symmetry is there. Therefore, these compounds maybe these groups should be considered as the enantiotopic groups. Okay, for example, we have the such compound HA and HB is there. Okay, such type of compound is there, and these two groups are, whether these two groups are enantiotopic groups, then if suppose it is having the plane of symmetry, then it is enantiotopic groups. Okay, if you consider, okay, like that, this groups is looking like that. Okay, plane of symmetry is there. Okay, two equal parts divide these two groups. Okay, when your plane is passed, these two are the exchangeable one. Therefore, these two groups are the enantiotopic groups to each other. Okay, like that way, if SN axis is not considered, we consider if SN axis is present, then your faces is the homotopic faces or homotopic ligands. But if there is no CN axis is present, only SN axis is present, or inversion is present, or plane of symmetry is there, and which exchanges to groups, then that is called as the enantiotopic groups. If we have previously seen the example, that is tartaric acid, okay, HA and the HB. Okay, these groups we consider as a enantiotopic group. Okay, when we looks these groups in our Newman projection formula, okay, like that way. Okay, in this case, center of symmetry is there, and if you consider these two groups, there is a center of symmetry through the center. Okay, center of symmetry SN axis is there. Same group is obtained. Therefore, HA and the HB is shown center of inversion. Therefore, this HA and HB is considered as the enantiotopic groups. Okay, like that way we can predict the enantiotopic ligands and the enantiotopic faces, the topicity in enantiotopic ligands and the enantiotopic faces we have seen. I hope you will get all these. You have get all these ideas. Thank you very much.